Analyzing graphs of quadratic functions. So here is our quadratic function. Remember, you can tell that it's quadratic because the power is 2, or the degree of the polynomial is 2. It says for each quadratic function, find the indicated information. So starting off with this, we're going to be looking for the table, the graph, the axis of symmetry, the max or min value. Okay, so first things first, let's go ahead and get a table and let's get a graph on this. Okay, so what I did was I put the equation into y equals, and then I do second graph to get to the table, and I moved my table around until I could see the vertex. And you remember, a parabola is symmetrical, so the vertex, you're going to see symmetry over here under the y. So see the 2 and the 2, the 11 and the 11, 26 and 26. So right in the middle is your vertex. So -2, -1. Okay, so we're going to use these points right here, right around the vertex. So I'm going to put the vertex in the middle, and then do one on each side. Okay, remember, you can also get your vertex out of your equation. Your vertex is going to be translated 2 units to the left, the parabola, the parent function, 2 units to the left. So that's going to be your x coordinate right here at -2, and translated 1 unit down. So your vertex is right here. That's why we call this form, when we're in this format, we call this vertex form, because it tells us the vertex. It has our transformations. Okay, let's go ahead and graph it. And so I like to graph it from the equation. You can graph it by plotting the points, but here we're going to go 2 units to the left and 1 unit down. Okay, and then using our stretch, our vertical stretch of 3, we would go over 1, up 3, and over 1 the other way, and up 3. And there's my 3 points that I need. Good enough for graphing a parabola, 3 points. Okay, your axis of symmetry is going to be your line that cuts the parabola in half. Okay, my parabola is not very good, but cuts it in half. And remember, vertical lines, let me repeat that. Vertical lines always start with x equals, and it's going through -2 on the x-axis. So this is x equals -2. And this number right here will always correspond to this number right here, 2 units to the left. Or you could look at your vertex, you could look at your x coordinate right here. Okay, axis of symmetry. Max or min value, we have a min because the vertex is at the bottom, so we have a min. And the value of this minimum is -1. Remember that your minimum value, so y equals -1. And this one is going to correspond to your y coordinate. Okay? All right, writing the domain. This is review. So you do not have to watch this unless you need more practice. Domain, infinitely to the left, infinitely to the right. So we're going to go -infinity to +infinity. Inequality notation. Remember to use your less than symbols. No equal sign when dealing with infinity. Arrow to arrow. And set notation. X is an element of all real numbers. Okay? Range. Okay, remember range is lowest to highest number. Okay? So our lowest number is -1. Our highest is an arrow, which means it's going to infinity. Now this is a closed dot down here, so we're going to use a bracket and parentheses for infinity. Inequality, same numbers, except the -1 gets an equal sign under the less than. No equal sign for infinity. Set notation, let's go down here where we have a little more room. Y is an element of all real numbers such that, and then we do have to write this condition in. And I used the wrong letter because I'm hungry and it's a lunch and I'm getting ready to go have lunch. There we go. Nice excuse, Mr. Kramer. All right. Y-intercepts. Remember, your y-intercept is where it crosses the y-axis. Well, we didn't plot that point, did we? But we can find it in our table, possibly. And sure enough, here is our y-intercept at 0, 11. So at 0, 11 is going to be our y-intercept. You can write it like that. Or you could say y equals 11. Well, let's not do y equals 11, because that would be a horizontal line. So 0, 11 is your y-intercept. X-intercepts, that's going to be where it crosses the x-axis. Okay? Well, not in our table. We could approximate them on our graph. But let's go ahead and use our calculator here to get our x-intercepts. Let me zoom in here real quick here. We'll get our x-intercepts. Let me see if I can. Okay, so we're going to do second trace to calculate, and our intercepts is going to be number 5. Okay, so I'm going to go ahead and find the 1 over here on the left first. So I'm going to move my cursor. There it is. Move my cursor above it. Enter. Below it. Anywhere below it. Enter. Enter. Did I not get below it? How about there? Enter. Need a little bit more light here. I can't see. Now I got too much light. Oh, well, that'll work. Let me start over. Second trace. Okay. Intersect. Number 5. Okay. First curve. Okay. We want to go above it. Below it. Enter. It's not working. I'm not sure why. Let's go ahead and approximate it. Okay. So 1 x-intercept is going to be at -1, -2, and a little bit more. So let's say -2, comma, I say 1 to -2.3, comma 0. And the other one, I didn't draw that very well, so let me get this drawn a little bit better. I'll be at -1. So if I went about 0.3 over, I'll go about 0.3 down, so -1.7, comma 0. Sorry guys that didn't work out so well with the calculator. You know, technology. 99 times it's user fault. So I probably messed up somewhere. But we'll go over that again in class. So for right now, we just approximated the two x-intercepts since they weren't in our table. See you guys tomorrow.